Welcome to the Martial Arts Dojo of Exam Strategy. Today, we are mastering a heavy-hitting topic, regression methods in machine learning, specifically tailored for the Cambridge AS and A-Level Computer Science 9618 exam. I want you to adopt a new mindset today, flow like water. Adapt your style to any question that comes your way. To set the scene, let's look at a real, highly challenging Cambridge past paper scenario. Imagine an 8-mark question asking you to evaluate the use of a polynomial regression model over a simple linear one for a given dataset. Now let me introduce you to two archetypical students I see all the time. First, we have Alex. Alex is brilliant, but Alex overloads their answers with raw computer science facts. They'll write a novel about what regression is, but provide zero actual analysis of the dataset. Then we have Sam. Sam always feels the time pressure, rushes through, and completely misses the command word requirements. They'll describe when the question explicitly asks them to evaluate. Both of these approaches lead to massive point deductions, and their test papers come back covered in red ink. But today, we are going to fix that. If you've been struggling to connect the dots on complex machine learning questions, you are exactly where you need to be. Listen to this direct insight pulled from senior examiner reports. They state, the difference between a B and an A star in computer science often comes down to how well you understand regression methods in machine learning. Think about that. This isn't just another bullet point on the 9618 syllabus. It is a major differentiator. It is the ultimate boss fight of your exam. The examiners use this specific topic to separate the candidates who just memorized a textbook from the candidates who can genuinely think like computer scientists. Alex memorizes the textbook and Sam panics at the complexity. We don't want to be either. The stakes are incredibly high here. But don't worry. By the time we finish today, you're going to possess the exact step-by-step blueprint required to completely dominate these questions and secure those top marks. So, to get you that A-star grade, here is the roadmap for today's training session. First, we'll establish the core principles and foundations. Second, we'll map out the procedural framework. Third, we'll unlock the method mark strategy. Fourth, we'll dive deep into critical analysis and evaluation. And finally, we'll review the top examiner warnings. We're going to move fast, so stay focused. Let's step onto the mat with Section 1, Core Principles and Foundations. This is all about bridging the gap to an A-star. Now, to do this, we need to talk about the strategy reveal. You see, the secret to tackling these machine learning questions isn't knowing more code than everyone else. It's understanding how Cambridge structures their assessment objectives. Every single question is built around specific command words: identify, describe, explain, evaluate. Sam lost marks because Sam treated an evaluate question like a describe question. To beat this, top students use a highly specific structuring technique. We call it the PEAL framework. That stands for point, evidence, explanation, link. Keep this in the back of your mind because we are going to be using it extensively to rebuild the way you write your answers. Let's look at why the PEAL framework is so necessary. There is a stark contrast in how students study. On one side, we have superficial breadth. This is Alex's trap. It's just memorizing disconnected facts, like memorizing the equation for a straight line or knowing that gradient descent exists. On the other side, we have analytical depth. This is a connected, conceptual understanding that is completely transferable to unfamiliar contexts. For example, understanding exactly why a specific regression algorithm is actively minimizing the cost function and what happens if your learning rate is too high. Cambridge examiners strongly prioritize this analytical depth. You have to prove you understand the underlying mechanics of a regression model. Now, I want to play a quick game. I'm going to give you 2 sentences. You have 30 seconds to figure out which one uses the PEAL framework. Sentence A, linear regression draws a straight line through data, which is good for predicting things. Sentence B, a polynomial regression model is more appropriate here because the dataset exhibits nonlinear exponential growth. Applying a linear model would result in significant underfitting, thereby drastically reducing the predictive accuracy for future data points. Time's up. If you guess sentence B, you are absolutely right. It makes a point, provides evidence from the dataset, explains the consequence of underfitting, and links back to predictive accuracy.
Moving into Section 2, the procedural framework. Top-scoring candidates do not just guess their way through a machine learning problem, they systematize their solutions. They approach an exam paper the way a compiler approaches code, systematically, logically, and without skipping a single step. When you are hit with a massive, multi-part regression question, the worst thing you can do is just start randomly writing down formulas. You need a standardized sequence.
Here's the exact 5-step sequence demanded by the Cambridge syllabus. First, identify the key elements. What are your independent input variables? And what is your continuous target output? Second, apply relevant regression principles, deciding whether a simple, linear, multiple linear, or polynomial model fits the data distribution best. Third, execute your analysis with absolute clarity. Fourth, Verify your results. Does the predicted data point actually make sense within the context of the problem? And fifth, present your findings in the correct format requested by the command word. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, when the exam shifts from pure theory to practical algorithmic thinking, that 5-step framework adapts into these 4 coding-specific steps. First, you need step-by-step decomposition of your regression algorithm. How are you calculating the error? How are you updating the weights? Second, you must select appropriate data structures. You can't just say save the data. You need to specify using 1D or 2D arrays for your training data sets. Third, you need efficient code implementation or pseudocode of the algorithm itself. And fourth, rigorous testing. This means mentioning techniques like trained test splits or cross-validation to ensure your regression model actually generalizes to unseen data rather than just memorizing the training set.
Welcome to Section 3, the Method Mark Strategy. This is where the magic happens. This is the transformation phase. We are going to take those red pen marks on Alex and Sam's papers and turn them into green check marks. This strategy is precisely how you win points on process, even when the math gets incredibly complicated.
Let me formally define the method mark strategy. It is an assessment principle where marks are awarded for demonstrating the correct systematic process and clear working, even if the final calculated answer is completely wrong. Let's say you're calculating a basic derivative to explain how gradient descent updates a weight, and you make a tiny, silly arithmetic error. Under Cambridge rules, you do not automatically score 0. If you explicitly show your execution, your logical reasoning, and state the correct formula before plugging in the numbers, you will capture the majority of the marks. This is the core of our computer science success blueprint. Alex used to just write the final answer and lost everything when the math was slightly off. Now Alex writes the formula, shows the substitution step, and provides the calculation. Boom! 3 marks secured out of 4 despite a math error. Of course, regression methods require remembering long, multi-step processes, so here is a highly effective memory hack. Use a visual story method to encode and recall complex algorithms. Let's take gradient descent, which is notoriously tricky to explain in words. Don't memorize the textbook definition. Visualize it. Imagine a hiker standing on the side of a massive mountain, blindfolded, trying to find the absolute lowest point of the valley in the thick fog. Every single step that hiker takes represents an iteration or an epoch. The size of their step is the learning rate, or alpha. The slope beneath their feet dictates the direction they move. That's the derivative of the cost function. If they take steps that are too massive, they'll completely step over the valley and bounce up the other side. That's what happens when your learning rate is too high. If their steps are microscopic, they'll never reach the bottom before they die of old age. That's a learning rate that is too low. This kind of mental imagery will help you recall the procedural steps perfectly when the exam pressure is on. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Section 4, Critical Analysis and Evaluation. We are now entering the interactive workshop phase of our dojo. It's time to elevate your answers into the highest order assessment objectives. I'm going to put you through 3 rapid-fire challenges. Challenge 1 is the data scan. Imagine a complex scatter plot on your screen showing the relationship between processing power and server heat generation. It curves sharply upwards. I'm putting 60 seconds on the clock in our minds right now. Scan it. What is the core trend? It's not a straight line, right? So if the exam asks you to suggest a model and you suggest simple linear regression, you've already lost the mark. The core trend is nonlinear. You must train your eyes to extract the overarching narrative of the data before you ever touch your pen.
Moving to Challenge 2, find the flaw. To do this, we need to understand evaluative thinking. It requires 4 things: considering multiple solutions, analyzing trade-offs, acknowledging limitations, and justifying decisions with evidence. Now listen to this flawed sample paragraph from Sam. Polynomial regression is the best method because it curves. It fits the training data really well. Okay, what is the flaw there? Why does that answer get a D grade? The flaw is that it completely ignores the limitations and the trade-offs. It fails the Peel framework. A true A-star evaluation must state the trade-off. Yes, a high-degree polynomial fits the training data perfectly, but it risks severe overfitting, making it entirely useless for predicting new, unseen data. You have to show the examiner that you see the whole chessboard, not just one piece.
Challenge 3 is speed writing.
Look at this matrix. This is your ultimate cheat code for compare and evaluate questions. Identify similarities and differences. Connect them with comparative words like whereas or conversely. Support with evidence and conclude. Let's do a 30-second mental speed writing drill. Compare linear and polynomial regression for a highly fluctuating dataset. Go. You should be thinking, linear regression provides computational simplicity, whereas polynomial regression requires higher processing power. However, for a highly fluctuating dataset, linear regression will result in high bias or underfitting. Therefore, despite the computational trade-off, polynomial regression is essential here to capture the true variance of the data. That is a perfect, examiner-pleasing paragraph built directly from this matrix.
We have reached our final section, Act 5, Top Examiner Warnings. This is where we lock in the final system. The examiners publish reports every year detailing exactly what students did wrong. Most students never read them. We are going to exploit them to avoid the most common traps.
Let me ask you a rhetorical question. Why do students consistently lose marks on multi-step calculations and method applications in this topic? If the procedural framework is so clear and the Peel paragraph structure is so logical, why do the exact same mistakes happen globally, year after year? Let's reveal the answers straight from the people marking your papers.
Here are the top 3 exam mistakes that will tank your grade. Number 1. Using the wrong algorithm for the given context. Applying a linear model to exponential data. Number 2. Forgetting to check boundary conditions during testing. For example, building a regression model to predict housing prices and failing to handle the edge case where the model outputs a negative dollar value. A house cannot cost negative $50,000. Number 3, providing generic answers not specific to the question's context. This is what we call the textbook trap. If the exam scenario is about predicting global weather patterns, your evaluation must explicitly mention weather data, atmospheric variables, and climate forecasting. If you just talk about data points and variables generically, you will lose the application marks. To beat this, you must apply our 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, a time management matrix to ensure you don't rush like Sam.
Please listen carefully to this urgent examiner alert. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. Do not assume the examiner knows what you mean when you say cost function or R squared. Before you launch into a massive, impressive paragraph analyzing the impact of a learning rate, take one single sentence to define what that term actually means. State that the cost function measures the average error between predicted and actual values. That one sentence anchors your entire answer and literally locks in foundational marks right off the bat, guaranteeing you don't walk away empty-handed. This all boils down to the ultimate framework, which is a continuous logical loop. Deconstruct, solve, evaluate. Deconstruct the given dataset and decode the command words. Solve the problem systematically, explicitly showing your workings to capture those method marks. And evaluate your model for reasonableness, justifying your decisions with comparative evidence. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So, I leave you with this final challenge. How will you apply the Deconstruct, Solve, Evaluate framework to completely transform your next regression methods past paper? Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.